Okay, today's example is going to look at a limit of a function using a table instead of a graph, although we will still come back to the graph because we're going to stick to most of the graphs in this class. But as the previous example finds, that limits, again, we're all graphical cases. Given a graph of a limit, we're going to look at one other method called the table method in this class. Again, sometimes it's helpful to look at both, right? Especially if it's really hard to understand. Both methods work great, and since you can find tables on your graphing calculator, it is nice to do both methods. All right, so I've got this function here, this rational function, x squared plus 4x minus 12 divided by x squared minus 2. I want to find the limit as x approaches 2 from both sides of 2. You'll notice, if I tried to plug 2 in, I would get division by 0, so the function does not exist at 2. Right? But again, the limit doesn't care. It's only interested in what's happening on both sides. As I get closer and closer and closer, approach 2 on both sides of 2, what's the function doing? Is it doing anything? Is it approaching another value? Is it shooting off to infinity? Is it shooting off to negative infinity? How is it behaving? So that's the question that's the whole point of a limit. So sometimes it's helpful to see a table example because it's kind of goes hand in hand with the graphical example. All right, so I've set up a table where I've picked values to the left and the right of that 2 we're approaching. We're going to approach 2 and we're getting closer to it. And we want to get close to it. So if you'll notice, my values are very close. All right, to the left of 2, meaning those would be smaller than values. To the left of the x value 2 would be smaller than it. So 1.99, 1.999, they're all smaller than 2. And you'll notice this means approaching because I'm putting a 9 at the end. I'm getting a little bit closer to 2. Every time I add a 9 to the end, I get a little bit closer to 2. I don't actually ever get to 2, but I definitely get closer to 2. And so what we do is we will want to figure out how is this function behaving. And so what I did is I took this function and I graphed it, just because we're going to look at the graph anyway. And then I found the function value for each one of these. All right, so again, I'm plugging them into the function. And so I'm taking this x value, right, these are the x values, and it's going to give me the y value when I plug that x value in. So I'm going to find f of 1.99. All right, I'm actually just going to write the value down so I have room. But that's what I'm doing. I'm plugging it in this function. And so when I plug 1.99 in, my function value, my y value, comes out 4.015. Alright, well what happens if I get a little bit closer to it? So I put another 9, so it's still on the left of 2, but it's closer to it. Well, the y value, when I plug that in, I get 4.0015, and you'll notice there's a pattern. Every time I add a 9, I get a 0 after the decimal. My handwriting is messy on this tablet. Alright, so 4 9s after the 1, you get 3 zeros and a 1 5. 5 9s after the 1, you get 4.000015. And so you'll notice a pattern there. Every time I add a 9 after this, so as it's approaching 2, right, this approaches, I can get as arbitrarily close to 2, meaning I could put 9 down here 1.9999999 1,000 times, right? That's pretty dang close to 2. You had 1.99999999999 1,000 times. Everybody would logically round to 2, right? You're basically at 2. You're not actually at 2, but you're really, 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 really ridiculously close to 2. Well, when I do that, my y values, well, I get another 0 there, right? So I get 4.00000, blah, 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 eventually a 1 5, but there would be 1,000 zeros there. Right? I don't get to 4, but 4.0000000 is pretty darn close to 4. And the pattern that emerges means the y value approached 4 on the left side. Right? You'll see that. It's getting closer and closer to 4 on the left. All right, so on the left side, it's approaching 4. Well, so this is on the left. Well, what's happening on the right? So we'll do the same thing, but on the right side, I've got to pick values close to 2 that are bigger than it. All right, so I did 2.01, 2.001, and then so on. And so these are approaching 2 from the right. And what's the function do? So again, I'm going to take my 2.01, plug it into this function to find the y value. So plug it into this function inside the limit there. All right, that's how I get the y value out. And so when I do, it comes out 3.985 when I plug 2.01 in. Alright, well, what's the y value when I put 001 in? 2.001. Well, 3.9985. And then add another 0 after the decimal. Means I get a 9 here after the decimal. So 3 9s and then the 85. And then the last one, I get 4 9s and then the 85. And so you'll see the pattern, right? 3.999985. I mean, if we saw that number on our calculator, most of us would round to 4. Right? And so when I'm coming from 2 from the right, so from the right, if my x value is 2.00000, blah, 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 1,000 zeros and then a 1, right? 2.0000000 1,000 times and then 1. Well, the function value, the y value with 3.99999, 1,000 nines, and then eventually an A5. But 3.999999999 is basically 4, right? We'd round that to 4. And so it's approaching 4 on this side as well. It never actually gets to 4, but it gets so stinking close to 4 that we say 4 is its limit. Alright, and so if we pick values that are on both sides of 2, getting closer and closer to 2 from the left and the right, you should see a pattern, a trend. Alright, you'll know, again, I said this earlier, but if you tried to plug 2 into the function, it gives you an error if you get division by 0. So it doesn't exist at 2, but the limit doesn't care that it doesn't exist at 2. It's just what's happening as I approach 2, as I get closer and closer and closer and closer to 2. Well, what's happening from the table as the function is approaching the value, all right, as the function approaches 2, what value does it approach? Well, it's approaching 4 from both sides. One side is approaching values bigger than 4, 4.000015. And on the right side, it was 3.99999. But it still approached 4, right? It's just approaching it from 2 different sides. And so the answer to this limit is 4. All right? Now, the function value doesn't exist. F of 2 is undefined. But the limit exists at 2. On the left and the right of 2 are approaching the same value. So this exists, and it is 4. Alright, so let's look at the graph, if you hadn't already graphed it. Alright, so the graph of this function. So again, I kind of zoomed into the important part. So if you look at my picture here, so it's the graph of that function that was in this limit. Alright, I zoomed in on the side that we were interested in. So I kind of zoomed in and just looked at the pot. There's another piece to it, but I didn't, again, I left that off because that's not the important part. We're only interested in, remember, x equals 2, right? And so the function did not exist at 2. 2 is not in the domain. F of 2 is undefined. However, from the left of 2 and the right of 2, right? So this would be to the left of 2, this would be to the right of 2. It's approaching this open circle to 4. And so it approached that y value 4 from the left and the right. And so the limit exists and is equal to 4. That's what the behavior, that's what that limit is telling me. That limit is telling me there's an open point there. I'm approaching that open point. It doesn't exist, but my limit does. I have a wall at 4. I can get as arbitrarily close to 4 from the left and the right. Alright, so some important things to make note of. Does the limit exist? Does f of s exist at 2? No. The function does not exist at 2. Does the limit exist at 2? Yes. So even though the function didn't exist, the limit does. Right? Sometimes they both exist, and sometimes they both don't exist. Alright, but the function could not exist, but the limit could. Right? That can happen. When computing limits, what question are we actually asking? Well, we want to know the behavior of the function near the x value, to the left and the right of the x value. Alright, so we're looking for the behavior of the y values, f of x, as x approaches, as x gets closer to x equals 2 from both sides. What is the function doing? Is it approaching a value? Is it approaching infinite? Right? Is it approaching different values? Is it approaching the same value? All right, so again, it's interested near the x value, not at the x value. All right, so when computing limits, do we care what the function value is at the x value? The answer to that is no. Now, sometimes it's nice, right? But we don't really care what's happening actually at 2 when we're looking at limits. Right? In this case, 2 didn't exist. What we're interested in is what is the function doing as I'm approaching 2? Is there a jump in the function? Is the left and the right approaching different things? Is there a hole in the function? Is the left and the right approaching the same thing? Is the function having infinite behavior, which would make asymptotic behavior? Right? Is that what it's doing? So again, what is the function doing near the 2? Right? And we'll get more into the infinite behavior and asymptotes in the next set of notes. All right, so we'll stop there.